Okay, so let me ask a few questions. So the last time I came to speak in KL was about 5 years ago. It was an audience of about 150 people, and I asked people who knew TensorFlow, and only 5 people put up their hands. So this is why it's 5 years since I've come back. So, so just quickly, how many of you actively have done deep learning, right, at some point? Oh, this is so much better than 5 years ago. This is awesome. All right. Okay, so I'm curious to know, what do you guys use? How many of you are using TensorFlow as a backend currently? How many PyTorch? Well, less than I thought for PyTorch. Okay. JAX, anyone using JAX? I know that my friend over there has used JAX for a long time. No one else is using JAX. Wow. Okay, so that is very interesting. All right, so some of my slides are going to double up with what Quan did. I'm going to probably explain things a little bit different. I thought also maybe today I will talk a little bit about some of the history of sort of deep learning frameworks and give you an idea of how we sort of got to today. Because there's a lot of interesting stories and politics and all this sort of stuff as well that we're going along. So a bit about me, I've been a Google developer expert for over 6 years now. I work in deep learning around language and dialogue systems mostly, a lot to do with large language models, and also things to do with generative AI. So I had the term generative AI on my slides in 2017. And when people were like, what's that? Now it seems like everyone is talking about it. And I will prove that in a second. I'll show you something funny in a second. I do a lot of stuff to do with startups. So personally, I've built 2 B2C startups with more than 1 million users around the world. I mentor for Google for startups. The current startup that I'm doing at the moment is a startup called Red Dragon AI. So I'll just quickly, the thing I mentioned about generative AI. So when I was looking for old Keras code last night, I noticed that this is from my old GitHub. And it shows you generative models 6 years ago, right? That we were talking about this. And back then, no one cared or no one was really interested. Now, everyone wants to know about this stuff. I have a YouTube channel. Quan mentioned that I have a YouTube channel where I tend to sort of ramble on and record some videos every now and then. If you're interested in LLMs, I mostly specialize in LLMs and building apps with LLMs and stuff like that. About our startup Red Dragon, so this was founded in 2017. We're a Google partner, so we specialize in doing a lot of things around consulting, prototyping, and also a lot of things around research. So we've had papers at pretty much all the top AI conferences, NeurIPS, EMNLP, NACL, etc. We had our first, papers about I think in 2018, to sort of give you an example of sort of we've been doing this for quite a while. All right, so deep learning frameworks. Deep learning frameworks themselves are not new. There's a whole bunch that have been going on. So personally, I got into deep learning in 2014. And back then, there wasn't a lot of things around, right? You literally had sort of like NumPy, which was great, but you could never accelerate it. The main game in town back then was a thing called Torch. Not PyTorch, but Torch, right? So PyTorch is a translated version of Torch. Torch was written in a script called Lua. How many of you ever used Lua? A lot of game engines use Lua. And it was okay, but then what it would actually do is you'd have to compile it down to C++ or something for doing this. Around then, also Google itself was getting into deep learning. And what they used to do is just have these what we call protobuf files. And they would design all the models in that, and then they would compile it down to something that they would use. So the other game in town was Theano. So Theano was really awesome. It came out of Mila in Canada, but it was very academic, meaning that it would break a lot, right? And often back then you would write code and you wouldn't know whether your code was wrong, whether the compiler was wrong, whether you got to remember that using GPUs for deep learning only sort of took off in around sort of 2012. right? So this is very early days. So when Keras came along, it was really like a breath of fresh air for a lot of people. Suddenly we had a sort of simple way to make models and to start, doing stuff with models. Later on in 2015, TensorFlow came along. And how many of you have used TensorFlow for a while, let's say? Or how many, anyone ever used TensorFlow 1? Okay, same hands. All right, well, we got a few people over here. So TensorFlow 1 was a real pain in the butt, right? With the way you had to pass things around with placeholders, with a whole bunch of different things. And this is where Keras, kind of took off, because very quickly Keras had this multi-backend system. And back in those days, you would just basically sort of say backend equals TF for TensorFlow, or backend equals TH for Theano. And they weren't that compatible, right? At the start, they weren't that compatible. Over time, they became a lot more compatible. And then we saw a lot of, frameworks get released. And so I've put sort of a few of these here, right coming up to sort of the more recent ones like JAX and Flax. And there's Haiku from DeepMind. And there are a whole bunch of other frameworks that came along and have just died, right? Most of these frameworks have died. Really, nowadays, the only serious frameworks that you've sort of got left for backends is TensorFlow, PyTorch, and JAX, right? Keras has always been the higher level API for these kind of things. So for TensorFlow itself, there was a big competition for high level APIs back in the day. So we had things like Pretty Tensor, Sugar Tensor, all these sort of weird, high-level APIs that people built, trying to basically make it easier to write TensorFlow models. The challenge is most of those didn't survive. The sort of two that Google got behind was one thing called TF estimators. So I don't know if people have ever seen TF estimators, which was in many ways was not a simple way to do things. And then the other one was TF Keras. And TF Keras was always the simpler way to do things. The challenge was, could you do advanced things with TF Keras? Another framework that was around then that was really important is a framework called Chainer. I'm guessing, has anyone ever heard of Chainer? You don't need to put your hand up, Junku. I know you will know it. So Chainer was actually made by a startup in Japan. Chainer, if you look at the code, between PyTorch and Chainer, PyTorch just ripped off Chainer, right? Most of the cool ideas, and don't get me wrong, I know Samith, who's the creator of the thing, and he will admit that they took a lot of the syntax from there. Just because, and then sort of Keras also kind of ripped off some of the ideas for the subclassing API, right? If you know the Keras subclassing API. Back in those days, though, the subclassing API didn't exist, so it wasn't simple to do a lot of these things. This is all changed over time. A number of these, how many have seen some of these other ones? So Microsoft CNTK, Microsoft dumped that very quickly. MXNet was AWS's thing. A couple of companies still use it. Most people don't. The other one that was really cool, and I put it in here as a sort of a mention, was Lasagna, right? So imagine a framework called Lasagna. And at the time, this was sort of in competition with Keras. And it was pretty cool. Now, the interesting thing, the guy who made Lasagna is actually a research scientist at DeepMind, right? And he got sidetracked doing that. And Francois got sidetracked doing vision models at Google. And it was only when sort of, Google realized, we need to sort of push this TensorFlow thing to make it more mass, that Francois got roped back into doing sort of Keras under the sort of terms of TensorFlow. And this led us to sort of TensorFlow 2, which, the early work for TensorFlow 2 was in late 2018. I know Kwan, Junku, myself, and a number of other people, we all met up in Beijing to talk about what should be in TensorFlow 2. Most of us sort of pushed the TensorFlow Keras sort of ecosystem of doing that. And in some ways, that was a good thing and a bad thing, all right? It was a good thing that, yes, sort of Keras ended up winning and doing stuff, but it also meant that Francois's hands were kind of tied for most of TensorFlow 2, in that everything that they had to do had to work perfectly with TensorFlow. And this is why you saw all the other backends get dumped, right? So Keras moves from being multi-backend to being singular backend. And then the start of early 2019 or in 2019, there was a decision made of that, okay, eventually we will spin Keras out again to be its own thing. And Keras Core is that spinning out. So it's actually sort of been spun out of TensorFlow as Keras 2.4, 2.7, whatever it is now, for a while. But the sort of thinking behind this was that, okay, if Keras Core can basically become its own thing again, it actually has the freedom to iterate and to basically pick up speed, whereas it couldn't do that under TensorFlow. Most people don't realize that TensorFlow is used a lot inside of Google, but it's used for putting things into production at scale. So, I personally, I would say TensorFlow is not an open source framework, right? It's a free framework that Google gives you that you can use. But if you've got pull requests about how to use it and stuff like that, almost always they never get accepted, right? Because Google's so fixated on getting this to run their production systems for search. But pretty much every Google product now has TensorFlow in it in some way. All right. So the idea of sort of spinning Keras off again and making it multi-backend again is actually really cool, in that we're probably going to see a lot of development going forward in this sort of space. And like Juan said, this just been announced publicly in the past 6 weeks or so. But I think going forward, so Keras Core actually is Keras 3, right? I don't know whether people have mentioned that or not. It will be, probably late this year or early next year, it will be unveiled as Keras 3 going forward. And the good thing is that the Keras IO team, or Keras team as they call it, they're now sort of much more independent than just the TensorFlow team. So it means they can do what they kind of want, and they can take cool ideas from other frameworks like PyTorch, like JAX, like that, and incorporate them into Keras. I do think this is a really interesting time for where we're going. So most of you say you don't know JAX. JAX is sort of where it is at the moment for research and cutting edge models. This is it's far more open source than TensorFlow, meaning that they accept pull requests. They basically a long time it's been developed. The development for JAX started in 2018, really kind of was launched publicly more in 2019, and has gradually sort of picked up speed. JAX is, the cool thing with JAX, and one of the things I'll try and sort of talk about a little bit today, is the whole idea of XLA. So I think Jungkook is going to talk about this afternoon when he talks about JAX and Keras more. But XLA is the underlying engine of TensorFlow. And there's been this sort of long movement to sort of like, okay, how do we free this up so that we can use it with other frameworks? So JAX was sort of one of the first ones. There's another big project inside Google called MLIR, which some of you may have heard of, which is basically trying to write a system where you can basically compile from any framework to any other framework, or any framework to XLA mostly. And JAX itself is being used to train all the new models, right? So pretty much all your large language models, your Palm 2 models, if you know some of the latest TTS models from Google, like Soundstorm, those sorts of things. Gemini, how many people heard of Gemini? A few people. So this is going to be announced later this year as Google's big new language model, which will power things like Bard and stuff. These are all being trained in JAX, and mostly they're being trained in JAX because of TPUs, right? So I'll talk a little bit more about TPUs as we go through. So anyway, multi-backend Keras is back, right? This is definitely a key thing now. And it's a cool thing for us as users. It suddenly means that we've now got more options. The challenge has always been if I personally, I love coding in PyTorch, right? So I can pick up something, I can get my idea working in PyTorch, something like that. And to be really honest, I haven't used Keras that much over the past few years. It was mostly PyTorch and JAX. And once I've got something working in PyTorch, if I want to basically scale it up to train on a TPU cluster or something, then I will basically look at, translating it to JAX. Now, where we're sort of going with all this stuff, and some of these are the same slides that Kwan showed, where we're going with the same stuff is I could make a model just in Colab, right, with like a crappy little T4 GPU or something like that, get my model working, I see, that, oh, okay, this works, chuck it into like a PyTorch backend, chuck it into a JAX backend, and then with not too many changes, I can scale that up to train on a TPU cluster of like 2,000 TPU cores, right? This is where things are sort of going to go with this kind of thing. Deep learning models are getting bigger and bigger all the time, right? You've all heard of, OpenAI, GPT-3, GPT-4. Supposedly they're talking about training GPT-5 at the moment, right? As all of these things are, and the size is getting an order of magnitude bigger each time, right? So you had like GPT-2 was 1.5 billion parameters. GPT-3 was 175 billion parameters. GPT-4 is supposedly 1.7, 1.8 trillion parameters. So each of these times, this is just getting an order of scale magnitude. With the large language models, we are now in sort of race conditions, meaning that over the next years, next 1 to 2 years, we will see probably at least 2 or 3 orders of magnitude getting better and bigger, right? So to do that, it requires just such insane compute. And this is one of the reasons why Keras has sort of moved to this. So anyway, hopefully you look at this this code. So when you can, it's pretty small, but hopefully you can see it. How many look at that code and go, oh yeah, I understand all that? I'm just kind of curious. When you sort of look at that Keras code and sort of see, and for those of you who don't, is it just because you've never used Keras, or there are bits in there that are different? Anyone can just shout it out. Or no one can shout out, right? So what I want you to sort of see is that this code is basically the same. So much really has not changed with Keras. To give you sort of, an example, so Kwan had this slide as well, but really this is not that different than things were 6 years, 7 years ago. So much so that last night, like I said, I went looking around my GitHub, and this is a model that I did I think in 2016, 2017, right? And you can look at this code, and it's basically this code would run today, right, in Keras Core. There's really nothing, that different. Now, along the way, there were lots of things different, and most of that was due to TensorFlow. Right? That to basically get things to work in TensorFlow, they were like, well, rather than us change TensorFlow, why don't you change Keras, right? And we're sort of starting to see the pendulum swing back, right? This is what I'm trying to talk about today, some of these things. All right, so there are a number of cool new things that have come with this Keras Core and with the way things are going. One of them is the whole sort of Keras ops stuff. So this is, where we're operating at basically a low level. We can just think about things purely as mathematics, and got these ops layers that are going to run that mathematics. So this uses a lot of NumPy stuff for doing this. And this is sort of the first part of allowing you to basically write things in any framework here. We've also got, if we have a look at just looking, yeah, you see this. We can also see that if we want to just write a layer in Keras Core now, really, again, things haven't changed that much since we went to the subclassing API. So here's a perfect example of doing the subclassing API, all right? So do people, when I say subclassing API, how many of you know what I'm talking about? Just quick show of hands, or I'll explain it. Okay. So Keras has the sequential API, right, which Kwan talked about there. That's basically just layer, 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 right? The next one along is functional API, where, okay, now I can pick things, I can wire this layer to go here, this layer to go here, this kind of thing, right? The problem with those, or the great thing with those is that you can just chuck it all together and do something. But what if you want to customize something? What if you want to actually go into a layer and say, well, I kind of want my layer to do something different. Or I want to have a special kind of dropout. Or I want to do, an attention layer for a large language model, etc. This is where the subclassing layer comes in. And this is where we're basically making a class. And that class will have to basically have certain functions in there. So if you look at this is a class for a layer. Right? So a layer needs to have a call function, which is what gets called, and it needs to have a build function for building it together. So this is just a very simple sort of dense layer. I'm not going to do too much into the math, but we've basically got some weights. So this is where we actually tell it, hey, make some weights that we're going to train in here. We can then basically, see this, we're doing a matrix multiplication down here. We're taking our inputs, times our weights plus our bias, right? Hopefully most of you kind of know that from machine learning. That's kind of, simple, right? This is making a very sort of simple thing, but you'll notice in here, there are a number of sort of advanced things that we might want to play around with. So the initializer, right? How do we start off with the weights? So one of the sort of standard way of doing it is Glore-up normalization. This is what they've got in here, but you might decide, what, actually, especially for some of the diffusion models and stuff like that, people are trying out all these interesting new different initializers. So if you wanted to make a layer like that, you would basically go for something, look at one that you've already got and then work out which part you wanted to change. So in the case of the initializer, you would just come in and change this here. Right. Here's an example of a dropout layer if we wanted to basically do this. And you'll notice that the cool thing here is that this code will work on all three backends, right? On TensorFlow, on PyTorch, on JAX. So it uses things like keras.random.seed generator. So that one of the things with JAX, which I'll talk about a little bit more, and I'm sure Junggu will talk a lot about this afternoon, is that JAX is stateless. So this is a kind of weird thing that people are not used to. And I'll come back. I've got some slides about that. But one of the key things there is it can be a real pain to do random seed generation with keys and splitting keys and all this sort of stuff. So basically here, when this is running with a JAX backend, it's just going to do it for you automatically under the hood. You don't need to worry about it there. Making a model. So most of you, maybe a lot of you don't want to make your own layers, but you do want to make your own models. With the subclassing API, this is how you would make a model, right? You do an init where you basically define your layers. So this is exactly like PyTorch, right? If you're looking at, and remember, exactly like PyTorch exactly like Chainer, right? So they all copy each other, all right? And here you can see, okay, we've got our layers there. We've got 3 dense layers here. Our call is going to define how we're actually going to go through them, so that basically we're going to pass in the X is going to be passed into dense layer 1, come out, passed into dense layer 2. You can see here where we're doing sort of 2, and then we're going into 1 where we're concatenating them here. So we've got a concatenation going on here. We're passing them into the dropout layer there, and then out through another dense layer on the out there. So this allows you to write quite a complicated model very quickly just using subclassing. So if you're sort of new to Keras or new to deep learning, the strategy you want to do is get really good at sequential, really good at functional, and then deep dive on subclassing, right? And really work on subclassing. And because once you understand the subclassing, you will understand PyTorch straight away. Right, you'll be able to pick up PyTorch really quickly, and you'll also be able to pick up a lot of the things from JAX really quickly as well. All right. So anyway, then you'll see that this is the rest of it is really standard, and this would work on all 3 frameworks. You wouldn't need to change anything for this. You will need to change some things, but other things I will talk about as we get to it. But just showing you that with these. With a lot of the basic here, it's just going to be out of the box. You can run straight on a lot of different things. So that was all, what hasn't changed. Well, what's new? So the cool thing now is if you do want to mess around with something specific from one of the other backends, you can then write code for that. So this would be if you want to write a custom loop or something like a different sort of. So this is here basically a token position embedding kind of thing. If you wanted to write this for the other frameworks, you could actually go in and use part of their framework for doing it. So you will see for the certain things, there are certain things in PyTorch where they've just got layers that TensorFlow doesn't have, right? And vice versa. And so this allows you to actually sort of get the best out of these things there. This seamless integration. I would say also to understand with this is that there are going to be times where someone's already written the code that you want. Right? A good example of this would be OptX. So if you look at the JAX optimizer library, OptX is written by DeepMind, right? It's the exact same library that they use at DeepMind for training their models, for doing a whole bunch of different things. So often they will have like the latest optimizers that are written from, research papers in there before they're implemented anywhere else. So if you're like, hey, I've got this model and I know it works really well, and I wonder if I tried that new optimizer I heard about, what would it be like? This is how you would do it, right? You just change your backend to be JAX. You would make a few changes to use that, the OptX library, and then you would basically run with it. So that's the sort of key idea there. And each of the frameworks has some things that are good and some things that are not good, right? I'm not a fan of TF gradient tape. Some people are. That said, TF distribute can be really useful if you want to scale something up, for doing that kind of thing. So each of these basically allows you to sort of pick something and then use it from that particular backend here. All right. So what are some of these advantages of Keras Core? I've kind of touched on some of these already. One of them would be the crosswork, data pipelines. So something, to students, one of the things I say is that deep learning basically breaks down to sort of 4 main bits, right? You've got your inputs and outputs, which is your data, right? You've got your architecture model. All right, and you've basically got your optimized loss, right? If you can understand these 4 building blocks, you can build any deep learning model. Like simple for MNIST, whether we're talking about GPT-4, all of these have the exact same things, right? So one of the key parts, the first is data, right? Getting the data into the format for the model. And honestly, this is where Google put a lot of work into it with TF data, data sets and stuff like that. They've put a whole bunch of effort into building not only easy to use data pipelines, but using pipelines that will basically run at scale. So, one of the challenges, so like say 5 years ago, and was right now that's still a big challenge. Don't get me wrong, right? But back then, like you would just be using, like you would be like, I don't care about the data because even if the data is going to load really slowly and run, it's never going to be faster than my GPU is running. Right now, that changed, right? At some point in time, that changed, and basically things like TPUs came along, and then you started to get the term called starving your accelerator, right? So when you're starving your accelerator is when you've got your TPU sitting there waiting for data to arrive, and suddenly data pipelines had to get a lot better. And this is where TFDS is one. TF data. Basically, Google went into this really big and did a very good job at this. So you've got all your things like your extract, transform, loading. I'm guessing ETL people, data science people here, yes? Do people know what ETL is? Yes? Okay, I assume people know their heads. All right, so one of the cool things about this is all of these pipelines were written by Google to basically be optimized for never starving a GPU or an accelerator. So even if you're running, even if a TPU pod with 500, cores in it or something like that, this will be able to work out that, all right, that's the speed that you're running at, so I need to be loading so much data ahead of time, caching it, batches, doing all that sort of stuff for it. And this is where they've done this for now almost every type of data. So we've got like NumPy, we've got pandas loading, we've got images, just stuff for images. We've got things for structured data and loading structured data, getting in there. And one of the big ones was TF records. So how many people have ever used TF records? Kind of curious. Okay, yeah, there's a few of you in here. So TF records is Google's way of converting data to a binary format that will basically get it into your model, as quickly as possible. And it's used a lot inside of Google. It's perhaps not as neat as for certain things, but for a lot of things, it's still used for this. And the whole reason behind this is these things. So this was on text, and these are basically the new version 5 TPUs that have just come out. So they're actually V5Es. And these are the only, so TPUs are the only thing that's liquid cooled inside Google data centers, right? That are hard that's liquid cooled inside data centers. And if you look at these ones, they're actually, I don't have a picture of the old ones to show you, but they're actually getting bigger, meaning that you used to have stacks of, you would get 5, so each one of these blocks here is what we call a pod, right? Each one of these is actually a TPU, and each one of those, so if I sort of mark that there, each one of those has 8 chips in it, or 8 cores in it, and each TPU board has 8 cores. You measure the pod by the number of cores. So these have 256 per pod. The old ones actually were about 512, 1024, depending on the configuration. Getting these together. So all the cabling that you see there is actually optical cabling, right? To get it at speed, they actually are using optical cabling there. So here's my point, is that when you've got something that can train as fast as this, right? And a lot of the new NVIDIA stuff is kind of similar with the speeds and stuff like that. Getting your data pipeline is really important. Now, why am I stressing this? Keras Core will let you use whichever data pipeline you want. So you can go, oh, I want TF data pipeline because that's really cool, and I've already written it, and I don't want to waste my time rewriting it again for JAX or for something else. But then I can have, I can feed that into a PyTorch backend or a JAX backend. All right. So this is something, and vice versa. If you already had written, your pipeline all in PyTorch code with PyTorch data loaders, etc., and you were like, I just want to try out and see, how fast would this model be if I did it in something else, you can do that as well. So it's all interchangeable. So we're literally going back to the building blocks or the Lego blocks, and we can just snap one on, snap one off kind of thing, right? You're not being forced because of what you actually picked. All right, next up, one of the cool things about Keras Core is pre-trained models. So most of you who've used Keras know Keras.applications, where there are a bunch of vision models. Keras NLP and Keras CV now have taken over that. But one of the really cool things now is that you can just load a PyTorch model into Keras and use a different and use it for basically fine tuning or doing transfer learning. So I've got a notebook for this. Okay, so if you look here, this is basically using the PyTorch vision models. So this is quite a well-known library where the sort of maintainer of that is using lots of, has basically any sort of ImageNet model They put it up there. This was made by one of the other GDEs that I think is one of the guys speaking downstairs today. I'm not sure about that. But anyway, the idea here is that you bring this in, and you can now use a PyTorch model, module, to basically bring it in and then fine tune on it and save it in Keras. And then you could load it, and I'll talk about this a bit more later on, but the idea is then, so now we can take that model, save it into Keras format, load that back in, convert it to a TensorFlow Lite model, which we can then go and put on a phone for doing, for running that model on a phone. So this sort of stuff, while it might seem small to some of you if you haven't done it, if you've done it in the past, you know what a nightmare this is like, just weeks of work, right, of converting these things. So the fact that we can just suddenly now load up one of these modules and go for it, I think is, kind of awesome. And it also means that we can take TensorFlow models for the first time and probably convert them to Onyx. Now, people aren't talking about that yet, but from what I've looked at the underlying stuff, I think that's going to be possible also. All right, next thing. So Quan touched on the whole, progressive disclosure idea. The idea here, and I'll just go through this quickly. Just think of an onion, right? You've got layers of the onion. Each layer that you take off, you get down to more of the sort of core thing. So the simplest layer is the sequential layer, then you go down to functional, then you go down to subclassing, and that's where you used to stop. Now you can even go down to stateless stuff, which I'll show in a second when we talk about that. So the cool thing here is that if you know how to write a Keras callback, for example, you can go and use your Keras callbacks with a PyTorch model now. Now that alone is pretty cool, right? One of the things that I would say was sort of weak with the PyTorch models is it was often more challenging to, they didn't have the nice simple callbacks that you could just go, yeah, I want some learning rate annealing, I want some, TensorFlow, TensorBoard tracking, all that sort of stuff. But now, because, with this whole thing, you can basically, again, mix and match, with these things here. We've talked about the writing a custom training loop already. Writing a custom fit loop, if you want to do that, that's something you can write, train steps and eval steps if you really want to get into it. Now, again, this is something that you might only use. So let me give you a sort of good world example of this. All right, we're training a large language model, right? We know that it's going to just output numbers. Okay, numbers are not great if I want to actually have someone look at it and go, oh yeah, it's starting to make sense or something, right? So what I can do is I can write an eval step that when it does that, it will basically convert it back to characters or something, so that we can actually see what we're getting out. Now that's not something that's necessarily automatically in there. It might be in actually Keras NLP. I'm not sure about that. But this is something that would be pretty easy to write now. Whereas before, if we were doing just the dot fit, we wouldn't be able to do that, right? We would have to basically break out of that, do a predict or something, take that, write a converter or that kind of thing. So a lot of these things, if you want to do something that's a little bit more advanced, it allows you to do that. All right, the new stateless API for pure functional programming. All right, so let me try and explain this. Most of us, when we think about deep learning, we think about, okay, here's my model, right? So let's imagine I've got my model, and inside that model are my weights, right? And inside, the model, there's also the math that operates on the weights. And I just pass in some data at the top or some data on the bottom, and then out comes, my result, right? And I don't have to think about the weights. I don't have to think about that because it's all in my model. Okay, that's not how stateless works, right? Stateless model means that the model is just the math. And I pass in both my data and my weights. So I'm saying, okay, here's my data, here's my weights, I pass it into the model, you operate on the data that I put in and do your matrix multiplications on that and the weights, and then you give me out both my data and my weights. And now the next pass, I pass the modified weights with the new data in, and I run it through again like that, right? So the model itself is totally stateless. Now, I think that's pretty easy for people to understand. The challenge comes with, what about if I need something in the model to have some kind of state, right? And if you think about it, the two classic examples of this would be dropout and would be batch norm. So people know what batch norm is? Batch normalization? Yeah. So the challenge with batch norm is it needs to kind of track things from batch to batch, right, to be able to do this. So this is where sorry, I should have explained that this is how JAX works. Everything is stateless, right? So you've got your data, you've got your weights. You also have another thing in JAX that I haven't talked about, which is your random number generator. So the cool thing about JAX is everything can be totally reproducible, because you can basically pass in your random number generator so that it will, generate your randomness, any randomness that you need, plus your weights, plus your data, and it's totally reproducible. So if I want to go back and see, okay, what happened at, epoch 15, step 37, whatever, that kind of thing, I can go back and it will be the exact same each time. So that's really good for a lot of things, but also comes at a price that we now have to think about. How do we handle things like batch norm? How do we handle things like dropout? And this is one of the, the frustrating things with just working purely in JAX. The cool thing that what Keras is doing now is they've got this stateless API where it can basically, you can make up a model and it says, oh, you want a stateless version of that? No problem, right? Here's the stateless version of that. And it will handle things like the other things that we talked about, like the dropout, that kind of thing. So that's definitely a huge step forward. And this is sort of like the fourth, going deeper down into the onion, right? If you think of it like that. Okay, so I'm running out of time. Distributed training. It's going to be much easier here. They've just launched just last about that there's a new JAX distributed computation in Keras Core. John Koshin, are you going to do that this afternoon? Are you talking about this? Yep. Okay, great. So I won't talk about it. All right. So this is really cool too, because this means you can start training things at scale. I want to show the code for that. All right. The last thing I was going to say, or the last main point I was going to make, was that you've got this extendability. You can go out, to basically take your model now and easily train in PyTorch, export out, convert to TensorFlow Lite, put on a phone, do things like that. That's going to make things a lot easier. There are some issues. So I was just going to show a very quick one. I'm conscious that I'm running out of time. So here's just a very simple transformer model that I put together. I trained up last night when I was playing around with this. So this will work fine at the moment in TensorFlow. You will run into errors with JAX and with PyTorch. So let me sort of explain. Some of them are going to be much harder to do, right? So the JAX errors will often be a lot harder to do just because JAX doesn't have some equivalent of something that's there. It will probably come over time, right? The other ones that is probably one you're going to see more is where, so if you look at this is basically putting together, so here I'm using the subclassing API to basically make all the layers, etc. Then here I'm basically putting together an encoder decoder to make a transformer, right? So if you think about it, encoder, decoder, they're all like little mini models. Okay, when I put this together and run it in PyTorch, I will get an error. Why? Because it can't trace through all the modules nicely. And really, it's just that it can't trace through the shape, the tensor shape that's going on. TensorFlow, because it was sort of built for this, can actually go back through as a graph and work out the shapes of the tensors quite nicely. The way to fix that is just to do the mini model.build. So I hope, if you've seen this, if you've played around with Keras or anything like that, you'll know that the .build function takes it from being eager to actually start, making it as a proper model. That will fix that, here. That's something that you can. So if you do run into that error, just try that out. All right. Wrapping up. Speed and generally JAX is always going to be faster than everything else out there at the moment. So you're getting the free element of having a nice, easy to use Keras with the JAX backend. something that's probably going to be the quickest. There are certain models that PyTorch and the eager execution will actually do better, but generally anything you can use XLA is going to be faster. Even the TensorFlow versions of this are using, from what I can see, are using full XLA, and I find them to be faster. That transformer model was able to train up a language transformer in like 10 minutes, 15 minutes. It's a very tiny model, but it works. It gets something quite nice going on there. Maximize available ecosystem surface. Again, I've sort of talked about the ability to go to TF Lite, to go to TFJS, to go to these other libraries when you want to convert something for production. Is going to be really useful for a lot of people. The same is someone asked about C++. You could use, TF serving to do stuff with C++ and XLA and stuff as well there. That's pretty much it. So the slides were a bunch of people. I took some of Francois' slides, some other people's slides. Questions? Go for it. No. Okay, so you got your model, right? Your model is just mathematics. So if you think about it, the cool thing with JAX and the stateless API is the model is mathematics, right? And then the data and the weights, right, are just what we pass through the mathematics. So with things like PyTorch, TensorFlow, and Keras, before, everything was kind of the weights and is being baked into the model. So you don't realize that actually really what I care about is the mathematics in here. The weights, is sort of a separate. So it's actually, you've got your data and your weights, and then the model itself is the math. The stateless API is basically able to take a model and make it run with no weights where you pass the weights through. So okay, it's still the same, because if you think about it, you're passing the weights through, you're passing the data through, you get your output, you've then got your labels or whatever. You can basically take a loss against that, and then you perform your gradient updates then against the weights, right? And then you get a new set of weights, and you go back. Now, one of the cool things is you can actually even store the weights off, so you can sort of look to sort of see patterns in the weights or things like that as well. It's for JAX. It's not really for TensorFlow, right? TensorFlow builds a graph where they bake in the weights, they bake in all that stuff, similar to PyTorch. JAX is kind of stateless. Your model is stateless, meaning that you've just got the mathematics there. You have to bring the weights to it. Okay, great. Other questions? One here and then one here. Yeah. Do you want to just shout yours?
So does this provide on GPU or
Good question. I haven't seen a lot of talk about that at the moment. You can definitely use TensorBoard. My guess is that that will still work, and there's a profiler in TensorBoard for doing your GPU and your TPU profiling. I haven't seen any talk about anything sort of new in that regards. So it is a good question. How well will that work with other things? My guess is it's going to work pretty fine, right? That anything that you can do with TensorBoard, you'll be able to do with the Keras and TensorBoard. Okay. Show the progress in what's being trained. In regards to what? In regards to like your loss, or in regards to Okay, so honestly, I think the best thing for that nowadays is bias, right? The other thing tracking, the reason why I asked whether you're talking about parameters and stuff, is the other thing is just like broken hardware, right? So what people don't realize that when you're training a large language model and you've got say 2,000 GPUs or something, they break, right? It's not like, and so you need a way to know that, oh, okay, this GPU has failed, and then swap in another one on the next batch or something, or that kind of thing. And there's a lot of interesting tooling going on now of how do you resume a broken run. So one of the flaws with, say, PyTorch, to basically get things in the state that you want. If you think about, like, when you do a random shuffle and you're halfway through training an epoch, you don't want to do another random shuffle on the whole data. Otherwise, you're clearly going to train on some things again. So a lot of tooling at the moment is going into knowing that, oh, okay, we broke on at 2/3 through one epoch. So we've got this data that we've already trained on, and we're just going to start again from this data, which is actually quite challenging engineering-wise. But for just looking at your loss function, that kind of thing, I reckon, personally, I think Western biases is the best. Okay. Do you have socks, by the way? You're good. Okay. Go for it.
So, like, right now, Keras supports level, right?
Yeah.
I suppose, like, I think by default it's processor. How about PyTorch that JAX does Keras support the installation or version?
Okay, so the versioning and stuff like that, you have to be a little bit careful. So if you're going to do a PyTorch backend, import TensorFlow before you import PyTorch. Sorry, no, import PyTorch before you import TensorFlow, right? PyTorch doesn't like TensorFlow. If it sees that you've imported TensorFlow, it just spits the dummy and will, stop, right? But if you import PyTorch first and it says, oh, okay, there's no one else here, and then you import TensorFlow, it will work fine. All right? So that's an interesting thing for you to try out. Things like that, I think, will change over time. I want you to also realize that it's not as much of a competition as people think. So Sumit is one of the key leaders at PyTorch. I've spoken to him about this when they were writing the TPU backend for PyTorch and stuff like that. And his attitude is that, look, all the frameworks can learn from each other. That we're so in the early days still that that it's better that we all just learn from each other what works, so that the newer frameworks are going to be better and better and better. So I think PyTorch will definitely probably work with the Keras team on this as well. Okay, all done. Thank you everyone.